Hello, everyone. Am I audible? Can any one of you confirm me in the chat or by unmuting yourself that am I audible? We will wait for few more minutes so that more people can join. I'm audible to you guys, right? You can hear me. We will wait for a few more minutes so that at least we can get some more people. Can anyone drop in the chat box and say that I am audible to them and you can hear me? Any one of you, Bhaskar, Sweetie, Jay Prakash. Thank you, Sweetie. I know it's already 5 minutes above our starting time, but I still want people to join because discussions are fun when we have more people so that we can listen more about things and discuss more about waste to energy subject. Till then, whoever is present in the meeting, can you just either unmute yourself or type in the chat box to which degree you all are pursuing, or if you are a professional, then just let me know who all of you are. It will give me a better idea about my audience. In the chat box, write what you are pursuing if you are in a college or a school person, or even if you are a professional. Okay. Also, from where you guys are doing your degree or profession. Just a little informal starting till we are waiting for others to join. Sweetie, from where are you doing your BTech?
I'm from Guru Ghasidas University, Chhattisgarh.
Okay, okay, nice. What about Jay Prakash? What you are doing? Are you a student? All of you just write in the chat box what you guys are doing. Then we'll start the discussion about our course in the meanwhile. Why none of you are typing in the chat box? You are here in the meeting, I can see. Okay. From where are you doing, Vijay? Let's communicate. You
Bangalore,
all are
ma'am.
learning. Sorry?
Bangalore.
From Bangalore. Okay, very nice. Which year?
Third year, ma'am.
Okay, okay, okay. What about others who are in the meeting? Let's talk. Let's just talk. We are not here to, right now, we are not in a formal discussion hour. What about Kritika Bhaskar?
Ma'am, I'm in second year. Kritika.
Okay, from where?
State University, Jammu.
Jammu. Oh, nice. So I hope this course is going well for you guys and you are with the course flow. I guess now you have week 4 lectures available to you, right? Anyone? Till which week you are in your course of this waste to energy conversion on NPTEL? These are not difficult questions, guys. You can just type in the chat box. I can understand that you might not want to uh, show your video, but in the chat box, you can tell me.
Can you repeat the question, ma'am?
Yeah, I asked which year, which week course or videos are available to you for this course on NPTEL. I guess it's week 4th, right? On NPTEL, you guys have access to, okay, good. So you guys are able to follow the course.
Ma'am, you are not audible, ma'am.
I'm not audible. Oh, uh, does anyone else have this problem? I'm not audible to them. Can you just tell me so that I can cross check my connection?
Ma'am, you are stucking, ma'am.
Who is this? Vijay, right?
Yes, ma'am.
I am not able to hear you properly, and I guess Sweetie says that I am audible and I'm okay. Can anyone else confirm me apart from Sweetie and Vijay whether I'm audible or not, so that I can quickly cross-check my connection and we can
Now you
start
are
with our.
audible, ma'am.
I'm audible? Okay, okay, fine then. So I was
Yes,
asking,
ma'am.
are you guys able to follow the course? Because it's week 4, you are almost halfway through the course. So how's the course going for you? For all of you, not specifically Vijay, for every one of you. This is discussion hours, guys. You can talk, we can talk, we can learn, not only the things which are in the lecture. Okay, so I guess I should not wait anymore. We are already way above our time limit. I'll just uh, start with today's discussion, but as usual, we'll first uh, recap ourselves what we studied in this week's course, for which I'm going to discuss the assignment. Can you guys see my screen?
Yes, ma'am.
Okay. How about now? Why it is saying paused? What screen you are seeing? Hello? Hello? Which screen are you guys seeing? Can anyone tell me so that we can start with our lecture today? Because I think I have some issues. Okay, my video is visible to you guys. Wait, I don't know why it is not sharing. Let me cross check. Sorry for the delay. I'm so sorry. I don't know why the slide number 1 is not showing. Okay, we can start with the second slide itself. It's okay. Whatever is, without wasting much time, we can start with this. What you can see now is the incineration part 2 slide, right?
Yes,
ma'am.
ma'am.
Okay, then we can start. So I hope you guys remember whatever we have learned in this week's class, though you guys are way ahead of me. I'm still on week 2nd. So let's just, I hope you guys can help me out in revising the things. So, yeah. So what was in this slide? What we learned in this? Can anyone brief me? Prakash, I'm not audible to you. Uh, I guess most of you can hear me, and those whoever are not able to listen to me, you can just quickly leave the meet and join again. I'll just type these instructions in the chat. Yeah. So yeah, any of you quickly, what we understood from this slide, what was the motive behind this slide? Guys, everything is written here. You can just, it's not too old, just week 2. What was it? Without active participation, how I'm going to discuss questions with you? With discussions, see, this is what happens when we are discussing things. It makes our mind more prone to understanding, and it helps us in understanding more clear, like getting more clear understanding about the concepts and the things. It's like a revision for you. So this will help you in solving your assignments as well as helping you in preparing for your final exam for the certification or the credits for whichever you guys are working. So it's okay, even if it is wrong, we can discuss, no worries. But what you remember from this slide, or what was the basic motive behind this slide's information? You can type in the chat box also. I don't have any problem. If you don't want to unmute and say, you can just type in the chat box. Anyone? Okay. So can you guys at least tell me that you didn't understood whatever is on this slide, so that I can start explaining. You didn't understood what was on this slide? Okay. So it's a very basic slide. It's a theoretical thing. So basically, we will discuss first incineration slide also. I don't know why I was not able to share it. But in this, what we are doing is we are just getting to know what types of incinerators or combustors are there. I hope you guys remember the difference between incineration and combustion. Most of the time, they are used simultaneously, which means if you are using incinerator or you are using a combustor, they can be used synonymously with each other. So basically, incineration is a process in which we use high amount of heat to combust the material, and mostly this material is a waste material. The one of the major reasons why we go for incineration and combustion is to reduce the amount of product. Meaning, for example, if you have 100 kg of waste product, so if you are going for incineration methodology, which is a thermochemical process of generating energy, we can reduce that amount of that 100 kg of waste materials to few kgs of ash, which can be easily uh, discarded, or which can be easily taken care of, because taking care of 100 kg of material is a difficult task. We don't have space, we don't have any many landfills which are not up to their capacity, right? So if we can reduce the amount of waste material to be disposed of, it will be a good thing to do. So incineration is one such kind of a process. Along with, there are majorly three terminologies which we use commonly in thermochemical process. One is incineration, second is combustion, and third is, anyone? Anyone can tell me what is the third one? It is similar to incineration. It differs in the end product. Anyone? I need your active participation, guys. Any one of you? You have studied this process, and we have solved some questions also in the previous class regarding that process. It was a flow diagram, and it was asking what the process is. It has given us the input. There was a black box which says that it is a endogenous process, and the end products were CO2, H2, and char, with high temperature in between, obviously. What was the process? the process was pyrolysis. I hope you guys remember that pyrolysis, incineration, and combustion, these all are thermochemical ways of generating energy from the waste product, and also in reducing the amount of waste for which you need to take care of it before dumping it into the landfills or disposing it off. So there are mostly two common types of combustion according as you can see in the slide itself. First is fixed bed combustion, and the second one is fluidized bed combustion. So what is fixed bed combustion? Can anyone tell me? You have read the slide, right? You have attended Professor Mandal's lecture also. Just give me in brief what was fixed bed combustion. Anyone of you? You can type in the chat box. You can unmute.
Ma'am, can you please repeat the question?
I just want to know what is fixed bed combustion. It is a type of combustion process. It is a type of combustion system, fixed bed combustion. What was fixed bed combustion? It's written on the slide, guys. You can read it, you can understand it, and you can make me understand. Fixed bed combustion is basically a combustion process, okay, where complete process uh, performed on bed. Rohan, can you use a more waste to energy related term for bed? Can it be a grate? Correct? Because bed, obviously, fixed bed is in the name itself. Bed can be anything, but in this specific thing, we can say that there's a structure, long structure, a combustor, which we call. It will be having a fixed bed on which your raw material or your waste material will be there, on which air will be passed and heat will be passed for complete combustion of the material. Then second, as you can see here in the fixed bed combustion definition, that fixed bed combustion system include what? It includes underfeeder stroker and grate firings. Primary air passes through a fixed bed where drying, gasification, and charcoal combustion takes place in consecutive stages. The combustible gases are burned in a separate combustion zone using secondary air. So what is exactly, yes, a type of boiler, correct. So what is basically a under feeder stoker? It is a fuel which is fed into the furnace from below by a screw conveyor. Screw conveyor is nothing, it is just a way of transporting stuff towards the machinery, as you must have seen in certain movies or even in some documentaries of our industry. There is a continuous conveyor belt on which either the initial product or the final products are rolling. So it is just a screw type of conveyor, and they are forced into the grate where the combustion process begins. They are small scale systems and relatively cheap. They are very easy to control. This is one of the primary types of combustors which were used. As one of the problem with these, or say older types of methodology, is that it can be only used for material which has low ash content. Why? Because as we can see that it will be fed from the bottom, right? So if you have more ash content, which means you need to provide more. If you have more ash content and more water content, you need to provide more air for it to be completely oxidized. Correct? So this is kind of limitation. Now we are moving towards processes in which the amount of energy input can be reduced because energy comes at a cost. So we are moving towards certain processes in which the cost of input energy can be reduced, and the quantity of the output energy can be maximized. Okay. Then, as it said, the second part of the fixed bed combustor was under feeder stroke, and the second was grate firing. So what is grate firing? what you remember from this lecture or this slide, what was grate firing meant? Any one of you? See, you guys are putting your time here. So let's utilize it to the maximum and discuss. Because these things you cannot discuss with Professor Mandal directly. He has given you the lecture. I'm here to clear your doubts. So make use of this time wisely. Correct? So any one of you who remembers what was grate firing? Okay, none of you. So grate firing is nothing. It is basically spreading the waste material on the surface equally or homogeneously. Okay, so that okay, where waste moves over grating. Grating is the bed thing which we were talking about. So air is distributed uniformly so that if you have a homogeneous spreading over a surface and you're providing heat or energy to it, chances of that heat getting equally to every part of the substance increases tremendously in comparison to when you have heterogeneous distribution of the material. Because at some places, chances are heat might go too much and it will cause the burning. On the other hand, chances are that the material is so dense that whatever the energy you are providing, it is not even able to penetrate the material, and the material is not even crossing its threshold to be gone for the burning stage or the energy producing state. Correct? So the thing is, grate firing, it can use materials with high moisture content and ash content as well as with varying particle sizes. Correct? So from this statement, we can say though uniformity is important, but still if we have variable particle sizes, obviously, because to an extent you can separate things, but not to the finer extent. So you will always have varying degree of particle sizes. So the amount of energy which you are inputting will completely depend upon the variation of particle sizes you have in your input material or the waste material. Different types of grate firing includes fixed grates, moving grates, rotating grates, horizontal or inclined grates, water cooling grates, dumping grates, and traveling grates. These are just some of the types of grates. You don't need to remember word to word what they are. At the end of the day, they are just a type of grate which helps the material to move from one place to another in a homogeneous manner. So what are some of the important moving types of grate design? There are some of the some of the industrial level grater designs. Every and each of these grates have specific roles and they are suitable for a specific type of material. So what can you tell me about the reciprocating grate? What you remember from the lecture? What was the reciprocating grate or what the name reciprocating means? Anyone of you? I know it's been a while for these lectures, but you might remember something, right? So what was it? What was the reciprocating grate? Okay, no volunteers for this question. So reciprocating grate it's basically a type of grate that resembles the staircase. Like we have seen our stairs, right? It has gradations at a particular height. The slope will decrease as well as declining or inclining depending on upon from where you are standing on the stair. It will increase. So this grate resembles stairs with alternating fixed or moving grate sections. The pushing action may be in the direction of waste flow or in an upward motion against the waste flow. This means that it is basically transporting waste material from one place to the another. So if you have a stair type of something, chances are if a stair is moving like this, right? So if it is moving in the, your waste is here and it is moving in the direction of this, like this. So by this motion, what will happen? Some of the material which is based upon the density and the mass of the material, it will separate. And for example, if something is lighter, it will pass to this grade and again it will pass to this grade. So at the end of every stair or every end of this process, we will be having a homogeneous, somewhat homogeneous mixture of the waste material. The second is the rocking grate system. So can anyone tell me what was rocking grate system? It is mentioned here. Can anyone just read from the slide and tell me what was rocking grate system? Okay, so rocking grate system was based, it is a pivoted type of a system, and it produces an upward and forward motion so that the material can be forwarded towards the grate. Again, all these are, you don't need to remember the terms. Everything is reflected in the terminology itself. Reciprocating means it's a to and fro motion. Rocking means it's a toggle type motion. Roller, as you know, roller is a roller motion or rolling motion. Rotary kiln is, again, it's a rotational motion. So from the name itself, you don't need to remember that definition. If you understand the meaning of the word itself, then it will be easy for you to remember what each type of grate means. So the roller type of a grate is a series of rotating stepped drums or rollers which agitate the waste and move it down the grate. The last one is the rotary kiln, as it is an inclined cylinder, and it's inclined in such a manner that it is inclined and also it is rotating at the same time. It causes a tumbling action to expose unburned material and advance the waste down the length of the kiln so that overall homogeneous heating of the material can take place. Talking about, these are just the type of grades based upon the criteria which we discussed above. First one is the reversed feed grade. What was special about reversed feed grade? Can anyone tell me what was it? I am audible to you guys, right? Or I'm just talking to myself. Can anyone confirm me in the chat that I'm still audible to you guys? Okay, cool. So, okay, you guys didn't understood much, or you guys are not just typing in the chat, because these are pretty easy things, right? These are just some theoretical things. These are not conceptual based things yet. So you just need to know, okay, these type of graters exist. These are the types of combustion. This information will help you. For example, if you are planning to design uh, a industry or anything on which, like, you want to convert waste material into energy, right? So you should know what components you are supposed to use for running such pilot plant, right? If you have wet type of waste material, if you have solid waste material, if you have municipal type of waste material, if you have animal or agricultural type of waste material. So depending upon the type of waste material, your process will be designed. So how can you design a process if you don't know what are the operations available? Correct? So one way of generating heat from any type of waste, here we are talking about municipal waste, biological waste, or other type of waste. One process is thermochemical way, right? For which we are discussing right now. In thermochemical process, the first part is incineration or combustion process. So for, okay, now we know, okay, we have a biological waste. to handle biological waste, we should go for thermochemical process. Okay, in thermochemical process, what are the processes available? We have incineration, we have pyrolysis, and we have combustion, right? So now what kind of a process will be suitable for my biological waste, which I have with me, for which I am planning to start a pilot plant, right? So for all those things, you need to know whatever is available to you. Without knowing whatever is available to you, how can you guys select whether this is the suitable most uh, choice for my thing? Correct? Am I making sense to you guys?
Yes, ma'am.
Yeah. So in reverse, the rolling bell direction will be opposite to the waste direction. Not necessary. Uh, Reversed feed grade, in a way, you are correct, Rohan. But if we talk about these classification, like on what basis they are based upon the type of grate they are, right? So reversed grate will keep the material stable for a longer time so that more of a heat, or PA is the primary air which we are providing, can be in the contact with the material so that it can completely combust the material for producing flue gas or whatever other type of products which will be formed because of incineration process. The other one is the roller grate. As we have discussed, roller grates will provide you the roller motion. And reciprocating grade, as I said, it is a reciprocating type of a methodology. So it will cross one by one. You can just quickly give it a Google search after this class, and you will get n number of images from a live plant, or like plant here means the industry, from live plants, where you can actually visualize how these in real life look. These are because just pictorial representation of it, right? And in my upcoming slides, I guess I have a photo of roller grate, and you can see like on what scale they are and why you need this information. Chances are you might think right now that, okay, this information is not useful to you, but in the end, when you are with your paper and pen and you are designing your plant output, or the designing of your plant, these information will surely help you out in designing and getting the best out of your waste material, which is the goal of the subject. The last kind is the rotary kiln. What was special thing, or what was rotary kiln? If anyone can tell me, be open. You can talk. Yeah,
Ma'am, the kiln is rotating, ma'am,
yeah,
as you can
and
see in the cement industries.
correct. Rotary kiln is mostly found in cement industry, which is a very correct point. And why we need rotation for this giant tube? Inclination, I can understand that it will reduce the input energy in pumping things. But why we need rotation or tumbling effect for this? Because if you're turning a giant tube, right, which means you are providing it energy via motor. And motor is ran by electricity, and electricity is costly. So why we need tumbling action? To ensure all feed is burnt. Good. Because if you keep it stationary and your heat source is here or your air source is here, right? Chances are whatever is on the direct contact with the surface will get burned easily, or will get all the energy. And whatever is above this direct layer, it won't get that much of energy. So if you're rotating it, what will happen is the thing which are not getting proper energy, it will come to the bottom, they will take the energy and they will again go at the top. So it will provide us proper mixing as well as the heating. Correct? So how basically we are things, not we, how things are burning on grates. So what was the motivation or the motive behind this slide? As we discussed right now in tumbling, it's a very basic physics involved in this. with related to parallel flow, counter flow, center flow, direction of flow. What do you mean by direction of flow? Direction of flow of what? PA and flue gas. It is not about the flue gas, it is about the waste material. The flow is with respect to the primary air circulation and the feeder or the waste material you are providing. If you are providing waste material at this end and you are providing your air also in this end, they both are moving in same direction, which means they are in parallel motion to each other. Correct? Second, if for example you are feeding your waste like this, but you're providing your air like this, so your waste is moving like this, your primary air is moving like this. They both are counter flow processes. Last but not the least is the center flow. Center flow is basically you are providing your feeder or the waste material here, and you are providing your air flow directly in the middle, where there's a region here where your air and waste material is getting mixed. So this is called center flow. So according to you guys, which one will be more efficient in transferring air slash heat to the waste material? Will it be parallel flow, counter flow, or center flow?
Counter, ma'am.
Counter. Huh. Can you give me reason why counter flow will be more efficient than other two? Max heat exchange. Correct. Or in easier terms, because not chances are not everyone can understand heat exchange. In easier terms, we can say, for example, your air is moving in this direction, your waste material is moving in this direction. This air will be in more time in contact with the waste material, so that whatever energy is present in the air can be passed through the waste material for a longer duration. Because if they are moving parallelly, they are not static, right? Whatever the material is here, the energy has already been taken by this material, but still they are moving at the same speed. So relatively, they are not changing with each other. But in counter flow, if air is moving like this, waste material moving like this part of the air has exchanged energy here. Now this part of the air will exchange energy with this part of the waste material, which means the energy or the air will have more time for the contact from the waste material for it to get oxidized or reduced or combust, whatever the process. This is a very generic process and can be applied in every scientific area, whether irrespective of biology, physics, or chemistry. Correct? Am I making sense to you guys? Yes, no, okay. Anything in the chat? I'm asking in between so that I remember that you guys are able to hear me and I'm not talking to myself. Good, great. Now this slide, it was basically telling you what? It was telling you the advantages and disadvantages of the different great furnace designs, right? Why we need to know this? Again, at the end of the day, this information is for you to know what are the options available for you, so that you can pick up those things depending upon the type of material you have with you, right? If you have low calorific value uh, biological waste or solid waste or MSW, right? We can go with parallel flow. If you have high calorific value material with you, you can go for the counter flow methodology. If you don't know what kind of a material you have, but still you want to get uh, at least the average of both the worlds, the high calorific value one and the low calorific value one, you can go with the counter flow. So what are the disadvantages associated with parallel flow, counter flow, and center flow? What can you think of, irrespective of whatever is mentioned here in the slide? According to you guys, what are the drawbacks of parallel flow? One, I told you the contact time or the contact area associated with the parallel flow, right? In parallel flow, the other problem is with the radiation. So what is radiation? Can anyone of you tell me what is radiation and what are different types of heat transfer mechanism?
Ma'am, it's a heat transfer mechanism by electromagnetic waves, ma'am.
By
Radi-
electromagnetic waves. Okay.
Other one is convection and conduction.
Ma'am,
Okay.
conduction, convection, and radiation are the three processes to transfer the heat.
Okay. Can you distinguish between conduction and convection? As someone has already told me about radiation, so can anyone of you tell me about the conduction?
Ma'am,
Radiation heat
conduction is my
Go ahead. Hello.
Ma'am,
Yes,
conduction in generally metals, ma'am. Convection in gas and fluids. Heat transfer occurring.
okay, but these are the mode of heat transfer, right? They are not the type of heat transfer based upon in which they happen. So what you are telling me is that, okay, in gases, convection happen, in solids, conduction happens. There is a basic underlying principle for conduction, convection, and radiation. On what basis these three things are classified? Like why we say, okay, these are the three mode of heat transfer. I'll give you a hint. It depends upon the uh, what to say. It depends on the medium they require, whether the medium is in direct contact or not. Hmm. Correct, Rohan, you are right. It depends on the medium of heat transfer. So if electrons are vibrating at a higher rate and they are moving from one place to another, the electron itself or the atom is itself moving from one place to another place. This is the source of heat. This is the farthest terminal. So if I'm providing heat from this direction, if molecules here are heated, because obviously this is the direct source of heat, the molecules here, the molecules are directly going from this end to this end. What is this mode of heat transfer will be called? The molecules are moving themselves. Will it be conduction or convection or radiation?
Convection, ma'am.
It's convection, correct. The other one will be, this is my heating source. These are my molecules. These are due to heating energy. They're vibrating too much, right? Because they have high kinetic energy. And they're transferring their kinetic energy from one molecule to another. And that is how the heat is traveling from this end to this end. This will be called
Conduction.
conduction. And the other one, my heating source is this. The molecules are not at all moving, but still this terminal is heated. This will be called radiation. Correct. So these are dependent upon the mode of molecule transfer, not in which they are present. I hope I make myself clear. Like I guess Vijay was talking and he described in terms of the medium in which things happen. That is not the correct way. It is not wrong, but when we are talking about defining things, they have some standardized setups on which you need to classify them. So why radiation is coming as a disadvantage for parallel flow? Can anyone guess it? That it is coming as a disadvantage. Any guesses? Not complete heat transfer, No, Rohan, I don't think so. This is the right answer. Anyone else?
Radiation become ineffective with their length, ma'am.
Yes, in a way, you are correct. So what happens is to get the same amount of energy transfer or heat transfer in comparison to conduction, convection, and radiation, radiation is the slowest one. So if you're providing 10 kilojoules of energy to heat certain thing, for example, conduction is taking X minutes, convection is taking Y minutes, radiation will definitely take more than X and Y. So to get the same amount of energy transfer, if the mode of transfer is radiation, we need to provide more energy for more duration of time. You get my point? That is why it is a disadvantage. Because we are having, if we have conduction process or a convection process, we are providing heat, and in few minutes, the energy is dissipated equally throughout the system. But if the mode of heat transfer is radiation, we need to provide energy, 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 and then only it will be distributed simultaneously in the system to give us the similar output as for conduction and convection. So what was the crux of this slide? As we said, there are two types of incinerators or combustors, right? First was fixed bed, which had two things. What were those two things? The grate and the feeder, correct? The other one is fluidized bed combustor or combustion process. So what is fluidized bed combustion? Any one of you? As the name suggests, it's fluidized bed and not fixed bed. It is not a test for you guys. No one is marking you or judging you. You can say whatever you want with respect to the with respect to the discussion of the work which we are having here. No need to worry if it is wrong or right. Heat transfer is through medium. Rohan, can you elaborate it a bit more? Whether you are answering me for the previous questions or this current fluidized bed combustion? And if it is for fluidized bed combustion, what do you mean by heat transfer is through medium? Means heat is transferred to bed than to waste. Okay. We can tell it in an easier way that not directly to waste. Yes. This is in simpler terms. Whenever we are, for example, in fixed bed, there was a grate, we were providing air, and that air was directly getting to the waste material, right? But what if we have a waste material which is very smaller in size because we have uh, separated it, and like one of the example for using which I can think of a fluidized bed combustion is that because you cannot release certain particles in the atmosphere, such as like small particles containing nitrogen content or sulfur content, right? You cannot directly release them into the atmosphere because they causes serious health hazards for the human as well as animals, and they causes soil pollution also. So what happens is if particle is of very small size, say less than 25 ppm, ppm here is parts per million. If the size is less than 25 ppm, you cannot directly send them to the atmosphere. They will cause some respiratory disorders in humans and some other like illnesses in animals, as well as they will get suspended in the air. They won't settle at all. So what will be the problems when particles are suspended in the air? You are breathing them in, right? Even your own system, your respiratory system won't be able to filter them out because the particle size is too small. So what will happen? They will get accumulated in your lungs. I hope that you guys know the structure of lungs. And if not, for example, wait. Uh, so if this is your body, suppose this is a lung, each lung has very small vacuoles in them. Vacuoles are nothing but just the smallest section of your lungs. So if some smaller particles are coming in, what will happen with time? They will get accumulated in your vacuoles or alveoli, we call them, correct? So this will lead to your decreased respiratory ability, which means with time, you guys won't be able to breathe properly. So these are very small particles. So if you are at such an industry, at an interface where you need to handle and take care of particles or material which is of very fine quality, you cannot directly burn them. Because if you're directly burning them on a fixed bed incinerator, what will happen? They will quickly evaporate and they will convert into SOx and NOx. Here, SOx and NOx are, I hope by now you guys know what SOx and NOx are, right? Which is again not a good thing. So we can use fluidized bed combustors in such processes in which the particles are so fine that if you provide some amount of airflow, they will just float in the air, right? But if they are floating in the air, we cannot directly provide them heat. So one way of providing heat is put a material which can carry the heat, and they can, with the help of collision, what will happen? The basic thing is silica or sand, right? It if you have seen some deserts, or you know that sand, it absorbs heat very quickly as well as it releases heat very quickly, right? That is why the desert area in Rajasthan and other deserted areas, the summers are very hot, but the nights are not that hot, right? So what happens is, if you're providing sand here and you're providing air and heat for combustion process, the sand particle will take the heat with themselves, and your small waste material is already floating in the chamber. What will happen? These sand particle will come in contact with the waste material. They will transfer the energy to these waste particles, and then the combustion process will take place. So in such way, in such place, we can use these fluidized bed combustors. Uh, is it okay? You guys got the point?
Yes, ma'am.
So fluidized bed combustion uses silica sand, limestone, dolomite, or other non-combustible materials for the bed material. Why we need them not to be combustible? What is the specific reason for them being non-combustible? It's a very basic logical question. Yeah.
Ma'am, if it's combustible, we have to change the bed again and again.
Or can this be said that if the material itself is combustible, how it will transfer the energy, right? Because it will combust
Yes, ma'am.
first itself, correct?
Yes,
Hmm.
ma'am.
So it generally operates at a temperature of 700 to 1000 degrees Celsius. Depending upon the air velocity, fluidized bed system can further be divided into two types, which is bubbling fluidized bed and circulating fluidized bed. Again, you don't need to go into the deep. You just need to know the principle behind it, and what are the options available to you guys, right? And what was this? This is basically again a type of fluidized bed in which a bubbling type of effect is observed when combustion is taking place. The next one in the category of fluidized bed is the circulating fluidized bed. Again, you don't need to worry about the terminologies which are mentioned in the figure. You just need to know what a fluidized bed is and what are its advantages and disadvantages over fixed bed combustors. Correct? So as we are talking about advantages and disadvantages, so first one, it is suitable for high moisture fuel or low grade fuel. The typical operating temperatures are lower than the fixed bed system. Why we are saying the operating temperatures are lower than fixed bed systems? Any logical reason which you guys can think of that why fluidized bed require less temperature than fixed bed temperature, than fixed bed combustors. See, we remember, right? We were saying in fixed bed, the heat is directly transferred to the waste material. And in fluidized bed, the heat is transferred to the carrier, the sand, silica, or limestone, or whatever, right? So we don't know whether the waste material is homogenized or not. It is to some extent, but not necessarily 100% homogenized, right? So to get the same effect, we need to provide it more energy. But if we know in fluidized bed, the sand is there, we know what amount of heat is required for the sand to get activated and combust the waste material. That is why the operating temperature in fluidized bed is comparatively low with respect to fixed bed systems. Third point is higher combustion efficiency, obviously. And last one is more suitable for large scale operations. And here they are saying large scale operations because I told you, because you need to work at the interface of environment as well as industry. So at the end of the day, why we are doing all these processes? We are doing all these processes so that we can at the end of the day recover energy, right, from the system, correct? So these are some of the average. You cannot say if it is 80%, it will always be 80%. There's always a chance of deviation from the reported things. So if we are saying that if we want to recover heat from the waste material, which we have just provided in air and heat as an energy, the recovery is almost 80%, which means if you are providing 100 units of energy to uh, combust your waste material, you can recover almost 80% of it in the form of heat. In the form of steam, again, it is similar to 80%. In the form of power, it will be 35, which is very less. And I hope that every one of you understand the importance of this, like why we say that we have energy crisis. Can any one of you connect my statement with the thing which is written here? I just said from the power point that this is your power and it is only 35% recovery is there. So your heat is 80%, your steam is 80%, but your power is not even near to 60%. It's only 35%. Correct? So why we say we have energy crisis? We have n number of sources for energy, right? We can develop energy from water, from from what else? What else we can generate energy, or we are generating energy nowadays? We have
Wind,
discussed it in the
biomass,
first class. Sorry,
wind,
wind, fossil fuel,
biomass.
correct? But as you can see that if we are burning waste and we are incinerating them, which means we are completely burning them off, nothing is left after burning a commodity, just ash, which is not suitable for energy production. You cannot generate energy from ash, right? Because it doesn't have any energy. It has some physical properties, but not the energetically proper material. So from the waste material, you can only recover 35% of the power, right? Which is very low. Hence, despite having n number of options for generating energy, we are not even nearby generating 80% or 90% of the energy from the sources which we have currently. Because we need to take bigger chunk of material to get little output of power. Okay. I hope this makes sense to you. Yes, no, okay.
Yes, ma'am.
The next one is obviously combination of steam power and heat and power. This is just for your overall information. Last one is environmental aspects of combustion and incineration. We have already discussed some of this while we are discussing, because the end product of combustion will be what? The oxides of the material, some of the compounds which are formed during the process, which are not inherently present in the material, some of the gases which will be formed due to the combustion process, and the removal of the material, right? So we are not gonna. Okay. This was slagging. Okay, what was slagging? If you guys remember. What was it? See, if you are even at your home, right? For example, if you are cooking something, let's take cooking on a stove. So if you are providing heat, right? The utensils nowadays, they are made with technology, so they don't burn easily. But if you're providing heat continuously, chances are the bottom of your vessel will be burnt, right? And it is very hard to remove that burnt if you're not immediately soaking them or providing very harsh detergent or soaps. Chances are you need to put more energy in cleaning them, right? So similar things will happen at a bigger scale also. If you have a boiler or a combustion chamber, right, you're providing energy to it, and there's a material there. So if you're providing high amount of energy or heat or air in this thing, what will happen? Due to temperature, things will get accumulated in the surface. Specifically, if it is a fixed bed type of combustor, things will get accumulated on the surface. And if things are getting accumulated here, it will indirectly hinder the heat flow. You get my point? Because my waste material will be my waste material. Wait, let me explain it in a better way. So, this is your bed. This is your flow of air, right? So, if I have fouling or already from the previous cycle, I haven't cleaned my combustor well, and this is a fixed type of combustor, chances are things might be charred here. They will be accumulated here. So for the next cycle, when I'm providing the same amount of energy, these two, my waste material will be here, right? Here. So now my heat has to travel the fixed bed distance as well as the material which is accumulated here. So this amount of energy might not be reaching to the waste material itself. In a way, we have decreased the efficiency of our system, because earlier we were providing 2 units of energy and we were able to combust the material because the energy was only need to cross this fixed bed barrier. Now, as the fouling occurs or the slagging occurs, the energy providing has to travel from the has to travel a distance of the fixed bed as well as the slag distance or whatever is accumulated there, right? So the same amount of energy won't work in this case. That is why slagging is a problem. I hope I made myself clear. Yes, no. Hello. Hello. Okay, I'll move forward. Okay, thanks. I don't think people are interested in discussions. Okay, it's okay. We will still keep discussing to whoever is staying there. Good for you. We will learn something new today. So these were just basic direct formula based things. I don't think we have problems today based on this, but again, even if I think Professor Mandal has solved some really good questions in the lectures, you guys can follow that and apply these things. This is just the index which is provided for slagging. So if your index is less than 0.17, things are not gonna slag. If the index is between 0.17 to 0.34, things are probably gonna slag. And if it is more than 0.34, it will definitely gonna slag, and you need to take care of this slag, right? So again, these are some basic designs for the plant. which I guess Professor Mandal has discussed quite well. These are for your general information, like what kind of plants are available in India, as well as in foreign countries, along with their energy production per day. Is it fine with you guys? Can we go to the next lecture? We will take very less time in discussing that. We can discuss gasification. And because incineration, most of the points I have covered, we don't need to go back for the first incineration part. There is something wrong with sharing. Wait. And then we'll quickly move to some of the basic previous year assignment questions, which will help you guys in understanding and solving current year assignments. What are your deadlines for second week assignment? Can anyone tell me? Okay, no worries. Okay, we can go with the gasification process. Can you guys see my slide for gasification from the NPTEL lectures? Okay, cool. So what is gasification? In very simpler terms. Again, gasification is synonymous. It's like all synonymous with pyrolysis, combustion, right? But there are very minor differences between all these three things. So converting waste into gases. Yes, we can say that to the maximum extent. Yes, we can say that. Not wrong. So gasification is a process that converts carbonaceous feedstock, including biomass and waste, into combustible gases, that is H2, CO, CO2, and CH4, with specific heating values in the presence of partial oxygen. This is a key point, that partial oxygen is there. In incineration slash pyrolysis, we have complete oxygen supply or excess oxygen supply, right? Then the produced gas is called as synthesis gas or syngas. So syngas can be used for various applications, including liquid fuels, diesel and gasoline, and production of Fischer-Tropsch synthesis. These are some chemical things which you guys need not worry about. If it is used in place of oxygen, the produced gas contains high amount of nitrogen and it is termed as producer gas. So the only difference between syngas and a producer gas, if oxygen is if pure oxygen is provided, what the products will be H2CO, CO2, CH4. They will be completely oxidized. And for producer gas, air will be provided, and air has a component of nitrogen in itself. Hence, the product will also contain a nitrogenous output, and then that gas will be called producer gas. So here it is the overall oxygen requirement for different processes. So if the ratio of oxygen upon coal ratio, here coal you can directly consider it as a carbon weight or carbon percent, right, in your product, which can be analyzed by how can you take the carbon quantity from a waste material. There is some analysis. Okay, I'll give you MCQ. Is it proximate analysis or ultimate analysis? From where you can get the fixed carbon quantity. We have studied this in the first week. Good. It's a proximate analysis. So we can get the carbon quantity from there. So if the ratio of O2 upon carbon is greater than 2.5, the products will probably and mostly will contain oxygen, water, and CO2. Correct? If we have the R content within 0.68 to 2.5, it will contain now some amount of H2 and CO. If the ratio is less than 0.68, it will mostly have char, CO, and H2. The process will be called pyrolysis. Correct? You don't need to worry about remarks. It's okay. It is just for information, but you need to remember what is the R value. R value is the O2 and the coal ratio. And if we have more R, the complete combustion is there. If we have in between R, we have gasification process. And if we have R which is less than 0.65. So if the ratio is less, which means the denominator will be more, right? So if denominator, which means the coal percentage is high, with the limited amount of oxygen, it won't get completely combusted into CO2 or H2O. So a char will be there, CO partial oxidation product will be there, and the process will be pyrolysis. So some basic chemistry which was involved for the gasification process, it is with respect to the energy. So I guess most of you are from chemical engineering background. Can you tell me what is delta H and what this minus 110.5 is good, or minus 393 is good, or plus 172 is good? Can I get some answers? Heat required. Delta H is heat required. Okay, minus H minus heat required. What do you mean, Rohan? Can you write in a bit elaborately? Delta H, enthalpy change. Okay. So minus value is good or plus value is good? Means endothermic. Negative means endothermic. Okay. Plus.
Negative means exothermic, ma'am.
Can you repeat, Vijay? What are you saying?
Ma'am, negative means exothermic or endothermic? It's exothermic.
Negative means exothermic. Yeah, I was gonna correct. I that is why I asked him about plus. I'm reading from the chat.
Ma'am, negative means heat is generating, ma'am.
So negative is exothermic, positive is endothermic.
Endothermic.
So minus is good or plus is good?
Minus is good, ma'am, obviously.
Minus is good. Correct. So Rohan, can you just check once that you are saying it's endothermic? Just cross check whether Vijay is correct or you are correct. According to me, minus means exothermic, which means the heat is releasing, and plus means heat is provided to the system. Hence, we are giving more energy in comparison to what we are getting. Correct? And also tell me. Then we'll go to, these are, as I said, what the major difference between syngas and producer gas is. For syngas, oxygen is provided. For producer gas, air is provided. And we can see that in the nitrogen content, the huge difference between a syngas and a producer gas. These are some basic reaction schemes which you can go back to the lecture, and like I don't think there is nothing much to explain. Professor Mandal has explained them in a quite good manner. Then these are the basic steps which are involved in the gasification process. The first one is the drying, then the pyrolysis, reduction, oxidation, and then ash cooling. Correct? These are some of the equations which are what to say. You don't need to know much about them. You just need to know the basic principle of gasification. These equations are here to help you out in balancing the output of a gasification product, because if air is there, air has nitrogen, has sulfur, which means the end product will have nitrogen and will have sulfur also. Correct? This is the important gas phase reaction when you have a sulfur compound and CO2 all together in presence of heat. Then these are some of the formulas. You need to remember them. As far as I know, you need to remember them. There is no shortcut way of surpassing them. So again, it is for syngas efficiency. Then what are the factors which are influencing gasification? The first one is the feed injection, the gasification agent itself, the type of heating, the temperature range on which it is operating, and the pressure under which it is operating. Because all these things will at the end will ensure whether the complete heat transfer is there or not. Correct? So why we go for gasification and not go for pyrolysis or combustion? Because there is less CO2 emission. And why we are looking for less CO2 emission? Because CO2 is a greenhouse gas. Correct? That is why we are moving toward this gasification process. The other is compact equipment requirement with a relatively small footprint, which means the energy required to run a gasification plant is less than in comparison to the energy required to run a incineration plant. Accurate combustion control and high thermal efficiency. Again, this is the basic flow diagram of how a gasification plant or the process flow looks like. This is just some of the conditions which were mentioned. Then here is the type of gasifiers. You don't need to worry much about the graph. You just need to know what type of things are present. As we know, moving bed, fluidized bed is similar. The principle will be same, and entrained bed. These are some of the conditions for gasifiers. Again, same thing. And now I guess we can quickly move to our questions, which you guys are waiting for. And here it is. Yes. Can you guys see my screen?
Yes, ma'am.
So, okay. So you guys need to solve now. All of you have to send me in the chat box the answer. If I have 50% of the population in the chat, then only I'm going to tell you the answer. Done? The questions are pretty easy and you guys are very smart. I know this. So let's go ahead. Okay. So what is this figure? Is it a rotary kiln? Is it a ball mill? Is it a dryer or none of
Rotary
these?
kiln, ma'am.
Okay, one answer. And I got second. Okay, I got answer. It's good. It's a rotary kiln, and I don't think I need to explain much about it. This is from the slide, we can clearly see, and this is the live, like from a plant I was telling you about. You can see the scale of this kiln, right? And it is from a cement industry, as someone has mentioned correctly. Now, second question is, correct sequence of biomass-based incineration process is it drying, then pyrolysis, then reduction, then combustion of volatiles and char? Or is it drying, reduction, pyrolysis, combustion of volatile and char? Third, pyrolysis, drying, reduction, combustion of volatiles and char. And last, drying, pyrolysis, combustion of volatile char and reduction. Answers in the chat box, please. Okay,
And
I
drying
got one
power
answer.
combustion of volatile.
You can just tell me the option number.
A. Option number
A
A.
option. Okay. So I have mixed answers now. One person is saying second, other person is saying one. More answers. Either you can unmute or you can type in the chat box. Two. Okay. One more answer and then I'll tell you what is the correct one. Is it one or two? Okay, we still have time, but let's see what is the correct answer is. The correct answer is first. Need not worry if you were wrong. It is directly mentioned in the lecture. The first, it will take the drying phase, then the pyrolysis and reduction phase, and last but not the least, the volatile gases and the char combustion phase. Is it fine? Those who were saying second, the thing is you cannot reduce the material in the starting phase. You need partial combusted material for the reduction. If you are reducing early, the pyrolysis will be the complete combustion process then. You got my point? You need to first pyrolyze, which means reduce the material to its like somewhat elemental state and then reduce it for the complete combustion of the product. Then, okay, so what this says is, what is the range of excess air requirement for effective combustion of waste and biomass? Is it 70 to 90, 5 to 50, 0 to 5, or 90 to 100? Answers in the chat box, please. Even if you don't know the exact percentage, just use some logic that we are talking about excess air. Can excess air be 70 to 90% of the air provided for the combustion? Few more answers. Few more answers, please. See, again, if you don't remember the exact number, just use some logic that if you're providing 100 units of air, will the excess air be 100 units again? It will be a waste, right? If you're providing just the double amount of heat required. So what will be the excess heat required? One more answer and then we'll discuss the question. Okay, cool.
It should be less, I think, because
Say.
ma'am, I think the excess air requirement should be less. Because as you have only said that it will go waste. So that's why I think it should be lesser in number, lesser in percentage.
Less than what? Less than the input air, right?
Agreed. Yes.
Correct. So see, it's a very logical question. You don't need to remember exactly where Professor Mandal has told you, okay, this is the range for excess air, right? Though he has told you directly, but it's okay, no need to worry. But if we take this question logically, we are talking about excess air, which means the combustion has already taken place. But for complete combustion, we need to provide it secondary air or excess air. So if you are providing, for example, according to the first question, we are providing 70 to 90% of the excess air. The air has already done some work on the waste material, right? Though not completely, but it has done most of the work. Most of the waste material has been converted or is accessible for energy production. Correct? So 70 to 90 makes no sense because 90% of the work has already been done from the primary air. Correct? Secondary air or excess air is provided for complete combustion. Partial combustion has already taken place. So 70 to 90 makes no sense. Similarly, 90 to 100 again. These two options will be eliminated first. The confusion will come only in the second option and the third option, which is 5 to 50% and 0 to 5%. Talking about 0 to 5%, if we are saying, okay, the partial combustion has already taken place and we need to completely combust it, we cannot provide 0. First of all, it makes no sense. Then if we are saying only 5%, so the efficiency, if we remember, the efficiency was around 35 to 80%, right? Recovery percentages. So 80% of the energy can be recovered, which means 20% is still going somewhere. Correct? So that 20% energy is going for the combustion work or the incineration work or other things or the other chemical processes. So that 20 won't be covered in 0 to 5% range. So from the elimination process, we can only go for the option B, which is 5 to 50%. Are you guys able to follow me? Like, was it okay? Because it's okay if you don't remember the exact percentage. This is the way how you can tackle some of the questions even in your current assignment or in your future examination, that if you don't remember exactly, You can just take the question and think it in a logical way. Correct? Now we'll go to the next question. So, gasification of the biomass and waste converts its organic part into combustible by incineration with oxygen and steam so as to obtain a secondary gaseous fuel of high calorific value, having no ash. Gasification reactions in fluidized bed gasifiers are normally carried out at about what degree Celsius? Like, what is the range? First, 400 to 500, 900 to 1200, 1400 to 1500, or 1700 to 1800. Okay, I have some answers. I need more answers. I'll give you guys 2 minutes. And I know it's a theoretical question, but just again, if you want to input some logic, you can. But I think it's a memory based question until unless you are not in the gasification plant. So it's a bit of a memory based question. So don't worry if you don't remember it. You can always go back to the lecture and revisit again those things. Okay, I have few answers. I'll tell you it's a memory based question, so we're not going to spend much time on it. It is 900 to 1200 degrees Celsius, which was mentioned in the types of gasifier slide, as you can see here, correct? Again, this one. Okay, which grate resembles stairs with alternating fixed or moving grate sections? We have discussed quite a bit on this today. So which grate resembles stairs with alternating fixed or moving grate sections? First, the roller grate. Second, the rotary kiln. Third, the reciprocating grate. And last, none of the above. Again, go to the words, what they are saying, and go to the question, what is the motion associated with the question? Then you can easily tell me the answer. Okay, I have some answers. I need more answers. It is a very easy question we have discussed today, and I have told you guys also that if you don't remember the exact meaning, you can always associate the motion which the grate is doing with the name of the grate. One more answer. Okay. Uh, Obviously, we know the correct answer is reciprocating grate. No much time to discuss on this. I have pasted everywhere. I've pasted the source from the lecture slide so that you guys, so that these slides can be imprinted in your mind and you can get better understanding and grasp of the things. This is the picture from the live plant. So as you can see, it has a stair-like manner of transporting or grating, correct? Then what is the R value or the ratio of O2 upon coal ratio weight by weight for gasification processes? Is it first is R between 0.68 to 0.25? Second is less than 0.1. Third is less than 0.68. And fourth is greater than 3.5. I'll give you 1 minute for this question. first, remember what R value is and what it signifies basically. And we are talking about gasification processes, not combustion, neither pyrolysis. So what we know about gasification, is it a complete combustion or a partial combustion? And then we can easily know about the R value. Okay, first 0.62. Okay, okay, I get it, the first option. Can I get more answers? I guess one more answer. Most of you have answered me, and whoever is not answering me, you can always just unmute and ask me if you have any query. So obviously the answer is 0.68 to 0.25, as we have already, like we have just discussed in the gasification, that if the R value is in between, the process is gasification. If it is more, it's a combustion, because complete oxidation will take place. And if it is less than 0.68, the process will be partial combustion. It will be associated with pyrolysis. Then again, I think it's a direct question. So if air is used in place of oxygen in gasification process, the produced gas is known as syngas, cake oven gas, producer gas, or gobar gas. I'll give you 1 minute for this question. Okay, I have one answer with me.
A.
Okay, someone is saying A. I have 3. Okay, I guess majority of you have told me the thing, but the answer is producer gas. Those who were saying
Ma'am,
syngas, remember, huh?
ma'am, in air now we are having 78% nitrogen and most of the element present inside it. Okay. So in that gasification process, if instead of oxygen, we are actually replacing oxygen with air, and air contains lots of elements like 78% nitrogen and carbon dioxide and oxygen and lots of things. So basically, if we are adding up to the gasification process, then the gas won't be like producer gas, because same gas is basically CO plus H2, right? So it should
Hmm.
be, I think, same gas.
No, this is,
I
see,
believe.
the definition which you are saying is correct. That air contains nitrogen content, it contains sulfur content and other elements also, right? Trace elements. So if we are providing air into the combustion process, obviously these elements will also go for oxidation. While if we are giving only oxygen, oxygen doesn't have other elements in them, which means the end product will be CO2, H2, and CH4. But if we have air which has nitrogen content, that nitrogen content will also be combusted or oxidized to produce NOx. NOx means nitrogen oxide, correct? So the syngas containing nitrogen is called producer gas. Whatever you are saying is correct, is that you have labeled the things wrongly. Syngas doesn't have uh, a like appreciable amount of nitrogen content, because even if you're providing oxygen for the gasification process, chances are it is not 100% pure oxygen, because if it is 100% pure oxygen, the combustible energy is so high that your plant is at a risk of blast, right? So even the oxygen which is provided for the gasification process is not 100% pure oxygen. It has mixture of other things. But if you are saying air, air definitely has nitrogen content, air definitely has sulfur content, which will be oxidized if you are providing air as a gasification for the gasification process, and it will be reflected in the produced gas. So that gas which contains nitrogen is called producer gas. And if you are still confused, you can always go back to the lecture and clear your concepts. And even then, if you are having certain problems, we have doubt clearing session tomorrow also, Sunday also, for the same thing. As we two things will be discussed. You can join there also and you can clear your doubt. Is it okay?
Yes, ma'am, completely fine.
Hmm. So now we have, I guess, three numericals lined up for you guys. So I will give you each, for each numerical, around 5 minutes. So your 5 minutes for this numerical starts now. And I think you guys might not remember the formula. So for your help and guidance, I'm providing you the formula also. So just try to solve it and your 5 minute starts now. And remember, this equation won't be used directly as it is written. You need to modify it a bit according to the things which are asked in the question. I haven't received any answer, so I'll give you guys 2 minutes more. Just give it a try. And we have already solved such a question in the previous lecture and previous week discussion lecture. The only difference is that in the earlier question, this formula was directly used, and in this current question, you just need to move things here and there for calculation purposes. That's it. I'll give you 2 more minutes. Are you guys able to attempt the question? Just try to attempt it. Otherwise, I'll give you the solution. And also, I guess this type of question was discussed in the tutorials also. Tutorials for characterization, I guess. Okay, I received one answer. Great. One more answer, and then I can quickly go to the solution. You can even tell me the approx answer, no worries if it is not matching the options available here. Okay, I think we can discuss the question. The solution, the answer is B, which is 1706. Tweety, you are correct. Good job. Then, okay, no worries for those who were not able to get to the answer, but I hope that you all were uh, at least were able to attempt the question. So whatever the things are given first, when the key to solving a numerical is first you should know whatever the things are given, what the formula is, and from the formula, whatever things you can extrapolate. Correct? It's a very like a standard mathematics basic. So your initial H or the heat is given, your initial mass is given, C1 is given, C2 is given, and C3 is given. I'm not going to explain what is C1, C2, and C3 as we have discussed already in the previous classes, and in the lecture also things are pretty well explained. And if you still have some doubts, you can always write in the forum or in the chat box here. I will take those questions. Second, if you want to discuss them, there's a discussion class tomorrow also. So you can read it today, understand. If you're not understanding it today, you can ask tomorrow. Correct? So these things are given, and this is the formula. This is the same formula but in the previous form. Sorry. Hello.
Ma'am, can you please show us the previous slide one?
Yeah.
Okay, ma'am. Thank you, ma'am.
Oh, no, it's no problem. Then this is the formula. In the earlier formula, this formula is for heating value calculation, but in the question it is asking for the water equivalent. So water equivalent is the W. So we just need to rearrange the same equation. If you rearrange it, the equation will become this: H into M plus E1, E2, E3 divided by temperature change. And then E1, E2, E3, as we already have C1, C2, C3, we can easily calculate based upon this formula again. And we can just put these values and we'll get to the answer. It's not that difficult. It's that you just needed to manipulate this equation a bit, and everything else was given. Correct? I don't think you guys have some issue with this. And again, same things I will repeat. If you have some issue, we have discussion class tomorrow also. Please do join them and try to take maximum out of these discussion hours. Here we have one more numerical. Please.
Ma'am, I wanted to ask that in the last class session, we were not able to admit the PPT that you have that you were actually.
Okay, those PPTs
Uh,
are not circulated to you or what?
Ma'am, actually, I wanted to get those PPTs.
Get the
PPTs
PPT
that
which
you
I'm
were.
discussing.
Yes, ma'am.
This one, now. I think these will be provided to you at the, I guess, end of the course or something like that. But if you want this discussion, these discussions are on the YouTube also. I will upload these
Okay.
lectures on the YouTube. The previous lecture is already uploaded
Okay. What
on
is
the
the name
YouTube.
of the channel?
I'll quickly share my screen after discussing all these questions. And I'll just copy paste in the chat box the link of that video also. Is it fine?
Okay.
These
Yes, ma'am.
things are already published in the YouTube. You guys can access it. Okay.
Okay, ma'am.
And I guess the links and these PPTs I have uploaded in the on the cloud, but I guess NPTEL team has not yet circulated it to you guys. There might be some reason, but it's already on the cloud. And no worries, you will get the slides. So I don't think so. You any of you have any question regarding this problem statement? Well, it is pretty simple and straightforward. Should I move for the next question?
Yes, ma'am.
So we have another problem statement here. I will give you 5 minutes. Your 5 minutes starts now. So the question is 3 gram of our dried agriculture waste is leached with benzene and ethanol at around approx 60 degrees Celsius. After leaching, the residue is dried in a hot air oven at a constant weight of 1.6 gram. This dried material is put in flask containing 150 ml of NaOH solution. The mixture is please mute yourself. There's a bit of disturbance. Kindly check your mic. Yeah. The mixture is boiled for 3.5 hours with recycled distilled water. After this, the residue is washed with distilled water till all the sodium ions are removed and dried. Determine the extractives and hemicellulose. I hope most of you are able to solve this question because this similar kind of question has been solved in the tutorial section. So I hope all of you can answer it. And your 5 minutes are starting now. I have pasted the link of YouTube where you guys can access the first week discussion. Okay, I have one answer with me. Uh, 2 more minutes, and then we'll discuss the solution to this question. One more answer, one more attempt. Again, similar type of question has been discussed by Professor Mondal, so I hope that it's not uh, a difficult question. I don't think it's a difficult question. It's just you guys need to just again put your logics. That's it. Nothing much. And even in this, I don't think there's in this, you don't need to even remember a particular formula. It is just a game of mass balance. So just one more answer and then we'll discuss the solution. Or say 1 more minute, I guess we should not spend more time. Okay, anyone of you is about to send me a answer? If yes, I'll wait 1 more minute, and if no, I'll discuss the answer or the solution. I think I should discuss the solution because most of you have tried. I hope that most of you have tried it. The answer is 46.6 and 10. So, sweetie, yes, you are correct. Well done. So, I hope you have done it with the methodology or the solution which I'm sharing with you guys. So, the initial weight or the M naught weight is given, right? Which is 3 gram of the material or the waste material. So after extractors, the weight is 1.6 gram, it is saying. After hemicellulose, the mass is 1.3 gram. Now we have masses after every step, after extractors and after hemicellulose. Now we just need to know the content of extractors and hemicellulose. How we can take any content of a thing, it is basically the difference of the thing to the initial of that thing. It can be amount or quantity or anything multiplied by 100. It will give us the percentage, right? It's some basic math. So the weight of extractors will be m naught minus m1, which will come to 1.4 grams. The weight of hemicellulose now will become, because the initial weight will now be after the extractors, in the m1 minus m2. the difference is 0.3. Now for percentage, for extractives percentage, the difference upon the initial multiplied by 100 for the percentage, it will be 1.4 upon 3 into 100, which will give you 46%. Similarly, for the hemicellulose, it will be the difference upon the initial into your 100, and it will give you 10%. Correct? So there was not even a direct formula in this. It was directly a question about mass balance. Correct? Now we'll go to the last question for today. It's a direct question. It is a formula based question. So if you remember the formula, well and good. And if you don't, I'm giving you the formula here. So try to understand the question, put the formula and give me the answer. It's a small question, so I'll give you 3 minutes for this question. Is that fine? So at least try and then let me know the answer in the chat box. Okay, I have one answer. One more answer. Okay. I guess we don't need to put this amount of time. It's a direct formula-based question. So the correct answer is 100. Again, sweetie, kudos to you. Hat trick for you. All the three numericals solved on time and correctly. Congrats for that. And for those who were not able to get to the right answer, but even able to attempt it, it's a kudos to you too. So we'll see the solution to this. As you can see from the equation itself, it's a direct formula. So the solution is pretty straightforward. It is literally you just have to put the given items into the formula itself, and it will give you the answer. So here B is 85, which is for blank, and S is your sample, 60. Your N is 0.1 here, and your sample volume is given as 200 ml. So if you calculate it, it will come as 100 mg per ml. So I don't think you guys have any problem in this. From my side, this is done for today. If you have any queries, let me know. And again, you guys can go today, revisit the second week lectures. If you have some queries, you can join tomorrow's discussion is also. Done? Do you guys have any queries? Okay, no problem. Welcome. So if you want to leave, you guys can leave.